Okay, well, we will go ahead and get started, and I'll continue to let folks in from the waiting room as they arrive. But I want to thank you all for joining us today for our public service perspective session. I'm really excited for this presentation around curbside recycling. For those that I haven't met before, I'm Mackenzie Kaharski. I'm the Special Projects Coordinator at the Voinovich School. Before we dive into the presentation, just have a couple quick housekeeping remarks. For those who are virtual, we just ask if you can stay muted throughout the presentation just to avoid distractions. But feel free to drop comments and any questions you have as they arrive into the chat. We'll also take questions at the very end. So you can either continue to put them in the chat or feel free to unmute yourself, raise your hand feature to ask out loud. Also want to note the session's being recorded, so that'll be available on our YouTube channel here in the coming weeks. Covers everything at this point. I will go ahead and turn it over to Derek Knekas. He will be introducing our speaker today.
Hi, everybody. Thanks for joining us. So I have the great pleasure of introducing Dr. Susie Boxman. She is the Director of Programs at EREF. If you don't know what EREF is, it's the Environmental Research and Education Foundation. It is an organization of professionals looking at the waste management industry in the United States. Susie has a PhD in environmental engineering from the University of South Florida. Her experience includes applying life cycle thinking to developing solutions to prevent the unnecessary waste of natural resources and material reuse. Her work in the U.S. has included within U.S. Environmental Protection Agency on sustainable material management and on the American Recycles Program. She's also looked at nutrient recovery from wastewater to utilize as fertilizers for novel food production systems, and solid waste management, looking at strategies to advance sustainable material management. At EREF, she manages the nonprofit's internal research projects on sustainable waste management. EREF directs and funds scientific research to advance sustainable material management practices. Dr. Boxman is an engaged practitioner in life cycle analysis and looking at developing innovative solutions for reducing, reusing, and recovering resources within our waste management systems. EREF has been a critical industry partner for our Natural Science Foundation Organic Waste Life Cycles at the Interface of Food, Energy, and Water Systems project, ALFUSE, which we have partners in the Voinovich School working actively on the project. So please join me in welcoming Dr. Susie Boxman.
Thanks, Derek, for that great introduction. Hello, everyone. I'm really excited to be here to talk to you a little bit about EREF, some of the work that we've been doing, and I'm just going to have to dive right into it with, hopefully, let me know when we get to the next slide. There we go. So with a little bit more background information about EREF, so we were founded in 1992 as a part of an organization called the Environmental Industry Association, which is now the National Waste and Recycling Association. So we ultimately became our own independent nonprofit because the industry recognized how important it was to have a standalone research entity in the waste and recycling space. And that's kind of where the Environmental Research and Education Foundation got started. And so our current mission is to advance scientific research and create educational pathways that enable innovation in sustainable waste management practices. And that's a bit of a mouthful. So really, in short, what we're working to do, and really kind of is reflected in the presentation material I have today, is we're working to light the way towards a more circular economy and working to integrate sustainable materials management into really the entire life cycle of materials. So we are a 501c3 nonprofit organization. We have a 4-star charity rating, which is really exciting. And this is just a little bit of a press release kind of about that charity rating, showing, how hard we work to make sure we are an independent and research organization for the waste space. And so what do we do? So we have a few different ways that we accomplish our mission. One of them is our research program. And through this, we are the largest provider of research grants in the waste and recycling sector. And so you can see that we've funded over 130 different projects since 1992 and provided it's almost $18 million in research funding since we were founded in 1992. Historically, we did have ties to the landfill industry. We kind of came out of a landfill-based organization, but as sustainable materials management has become a more prominent topic, and as we have grown as an organization, kind of going more towards the circular economy messaging, we've also worked to fund more non-landfill related projects as well. For those of you that are conducting your own research and potentially in need of research funding, I would encourage you to look at our website at our research grant program. So the next application deadline for pre-proposals is May 1st. We're currently reviewing the current cycle, and we have 2 funding cycles every year with pre-proposal deadlines of May 1st and December 1st. But you can find out more on our website about that. The other way that we provide funding and support the industry is through our scholarship program. So right now we have 28 active scholars. Last year we funded the most scholars throughout our history last year. And so we've funded almost $2.393 million in research scholarships direct to students. And so I know the deadline is really tight on this, but I did want to mention our application deadline for this year's scholarships does close on March 1st. So if you're able to scramble and are interested, you can take a look. I include the link on this slide for our scholarship program, but it's also something to keep in mind for next year if you're in need of potential research funding. It's a unique program in that we do fund our if you're awarded a scholarship, it's a pretty competitive process, but it does fund you through the duration of your program. And we fund both master's and PhD students. So something to keep in mind. So we also we're and education's in the name. So we do education. I think probably what's maybe relevant to folks here is our science sessions. So these are webinars that we offer. We're gearing up to start this again later this year. But at the bottom of this slide, I kind of included content of our science sessions that we did a year or 2 ago. That series of science sessions was pretty much focused on PFAS, but there's a lot of really good information there. And those are also available on our website if you're curious to learn more. But we also host technical meetings and we produce online content. So we do a lot of different educated related efforts to make sure that we're getting the data and research that we do out there. And the last piece of what we do before I get into kind of the research project that I want to discuss is our data and policy program. And so this is where I have been working with Derek on some of the internal research that we've been doing. We internally, we've produced over 22 reports since 2014. We have a number that we're working on right now. These are just some examples, some of those internal projects that we've done or are currently doing. The state of practice of organics management in the US is kind of what we're collaborating with Derek on right now. But we really cover a variety of different topics through our internal research program, from landfill related topics on leachate to more materials management topics like the organics management work or different sort of things like that. And so what I'm going to be talking about today is kind of in that table, the life cycle assessment of curbside materials report that we put out last year is really the topic of the presentation that I have for you right now. So diving into that, so I think most folks are probably familiar with the concept of a circular economy. And so this is the Ellen MacArthur kind of vision for what a circular economy is. And you can see that you have kind of the organic molecule kind of side of things, natural materials that's on the green represented in the figure. And then you have the more man-made materials and the potential circularity of those different resources that's on the blue side of this figure. And so my organization really focuses more on that blue side, specifically looking at these two areas where we're looking that we have a finite material resources, and in order to manage them effectively, one of the ways that we can do that is by potentially increasing recycling of those different materials. The idea being that we are resource limited, and to manage those things more effectively, to prevent climate change, and just prevent excessive resource use, working towards a circular economy is going to be really important for being able to do that. Recycling is one way to do that. And so this is predominantly looking at consumer goods. So materials, plastics, glass, and how can we keep those things within the system rather than disposing of them prematurely when they still have a usable life. So there is the concept of the circular economy, where in theory you can keep everything going around and around and around the circle for forever. The kind of sister concept to this is sustainable materials management, as defined by the EPA, which is a systematic approach to using and reusing materials more productively over their entire life cycles. And so there's an important point in the sustainable materials management concept, which is that it's not always possible to continuously recycle, reuse, or refurbish materials. Sometimes there are materials where the most appropriate pathway for them is actually disposable. Think about things that are potentially hazardous or toxic. When those things cannot be recovered or recycled, you do want to dispose of those items for safety purposes. And so using the sustainable materials management framework and kind of thought process, you can really look at what do we want to do with the waste that we currently have. Sometimes that could mean we want to recycle it. Other times it might mean we want to divert it. So like organics diversion, keeping food waste out of the landfill and sending it to composting or some other pathway. Minimizing waste is something reflected in a SMM, sustainable materials management principle, where we're just reducing the amount that's generated, which ultimately then means there's less that's going to be disposed of. And maximizing waste resources. So that's kind of a similar to recycling in concept. But ultimately, in working towards a circular economy, we have a lot of different options, and sometimes we're going to want to choose one path over another, and it's not always going to be recycling isn't always the right option. So how do we actually figure out which is the right option and when? And so one of the tools that we have to evaluate that is life cycle assessment, or LCA. And so essentially LCA is a framework for identifying and evaluating all of the energy and material uses that go into making a product or a process, and the potential environmental implications associated with that. So this figure kind of shows you, in order to create something, we have raw materials and energy that go into its production. There's going to be raw material acquisition, so you got to go get whatever it is in order to create that product. It's going to get manufactured in some way. You're either going to use, reuse, or maintain it until it's no longer functional, and then it's either going to be disposed of, probably through recycling or waste management type process. And as you move through each of those steps in the creation of this product or through the implementation of this process, there are different things that come out of it. So there's going to be atmospheric emissions, so like greenhouse gas emissions associated with the energy use of the manufacturing process. There could be waste produced in, there's excess material that isn't used in the creation of a plastic bottle. So some of that's going to get disposed of. There's other things that are created potentially that ultimately need to be disposed of, and just in general, other releases that can happen. So LCA gives us the tools to be able to look at all of these different things and calculate some of the different impacts of creating products. So in terms of recycling, it helps us answer certain questions like you see on the screen here. So why do we recycle? When does it make sense is an important one that I'm going to cover in the next few slides. Can recycling be worse than landfilling? You know, are there situations where the outputs associated with recycling could be greater than if you just put a material in a landfill? And how can we improve recycling? By evaluating these different questions, seeing where the downsides potentially are. Perhaps we can come up with alternatives to improve recycling, and kind of back to that sustainable materials management concept. Is there a way, by using LCA, we can look at, you know, what is the right pathway for this different material? So does recycling always make sense? Really what we want to do using LCA is evaluate kind of that life cycle of material that's shown in the figure here, where you have the extraction, goods, etc. And look at when all of those different processes are, by recycling the item, do the benefits outweigh the costs? So basically, that yellow line there is kind of where we're looking at the recycling of the different material, and does the outputs of moving that product from the recycling and processing phase back into manufacturing, are the offsets going to be greater than the potential contributions if we were to do something else with that? And so I think kind of the research that we show, or that I'll show in the next few slides, really highlights how can we evaluate when are those benefits greater than the cost using LCA as a tool. So the study that we specifically did is that we used life cycle assessment to look at a few different scenarios for waste management and collection. And so the scenarios that we looked at are outlined on the table here, where, you know, there are different options for how you manage your materials at the curb. And this is particularly relevant for situations where folks have curbside recycling. So in the US, that's not always true. There are multifamily units and other situations where people don't necessarily have curbside collection, but just kind of focusing on that group, looking at whether or not people have one bin, so just a bin to send things to the landfill, two bins, so you have your recycling bin and your landfilling and your recycling bin that you put out at the curb for collection. There's a 3-bin scenario, so depending on where you're located, you might have the option where you can send materials to the landfill, you have recycling, and then you also have yard waste collection that would go towards compost. And then the final option is you have a 3-bin system where materials are collected for landfill, recycling, and then you're collecting both yard waste and food waste for composting. And so by looking at all of these different scenarios, we can start to evaluate and answer that question of when does recycling make sense? And so this is kind of the results of that when we do the life cycle analysis. There's one important assumption here is that when you're looking at landfilling, landfills are designed in different ways, but this considers landfills that have gas collection. So methane is generated from landfills. Some landfills don't necessarily have systems in place to collect that, and it can be emitted to the atmosphere, which is not good. But most conventional landfills in the US, they have some sort of gas collection system where that methane can be flared. It then becomes CO2, still greenhouse gas, not great. And then this actually considers the final option where landfills collect the gas. It's then used for energy recovery. So that's really the best case scenario for what happens to the methane gas that's created in landfills. And when you factor that in to this life cycle assessment and look at all of these different scenarios for recycling and landfilling and composting, what you get is this scenario here, where the benefits do outweigh the costs. So what you're looking at here is where the things below the zero line on the figure are offsets. or reductions in greenhouse gas emissions associated with the life cycle results. And things above the zero are the impacts of, moving through the life cycle. So there's still some emissions associated with collecting the materials, moving the materials, processing the materials in a recycling facility, those sorts of things. But what we see here is that what's below the zero is bigger than what's above. So in this particular instance, where you have recycling, collection, and landfilling collection, a 2-bin system at the curb, the benefits do outweigh the costs. So yes, in this situation, it's better. But we looked at several different scenarios. So when we look at those other options, what do we see? So this compares where landfilling only is the baseline, the other 3 options for curbside collection of landfill and recycling, landfill, recycling, and yard waste, and landfill and recycling and yard waste plus food waste is that 3-bin system at the end. And so you see that when you look at all of these different situations, it really depends. So really the best option based on this study is that a 2-bin system where you're landfilling and recycling is going to result in the most greenhouse gas savings. So 38% greenhouse gas savings compared to just landfilling materials alone. If you do landfill, recycling, and yard waste, you still have savings, but it's only 1% compared to landfilling alone. And then if you incorporate food waste into that 3-bin system, you end up with greenhouse gas savings of 10%. So it kind of shows you that it really depends on the situation, and that recycling everything, particularly when you're looking at recycling food waste through yard waste or food waste collection, it's not guaranteed to result in greenhouse gas emission savings. Now, this sort of depends on how those materials are processed. And so part of what you're seeing here is how quickly these materials break down in the landfill. So yard waste takes a long time to break down, which can impact the methane capture from the landfills, and similar for food waste. So you're recovering some of those materials and that has advantages, but there's also potential emissions associated with that. And there's the additional collection. So if you have a 3-bin system, that's one more time you have to take the truck there to go and collect those different materials. So that's one of the reasons why the 2-bin system is better than the 3-bin system, right? Because that's, vehicles, unless you have an electric fleet, which isn't really present yet, most of these are diesel or natural gas powered vehicles that are going to collect these curbside trash and recycling. And so the emissions associated with that collection piece can be significant and as a factor when you add that additional bin as opposed to just going to collect things twice. So recycling, this shows that recycling does make sense compared to the alternatives, but just that there are some caveats with how much recycling that you're actually doing when you're looking at traditional curbside plastic and glass and metals and those sorts of materials versus the recycling of organic materials through yard waste and composting, or yard waste and food waste composting. So that really presents the ideal scenario though, right? So when you're looking at these life cycle assessments, what is often done when looking at the recycling piece is sort of assuming the best case scenario. So if you're recycling a plastic bottle, the ideal scenario is that the plastic bottle is collected in your curbside recycling bin, processed through a recycling facility, goes to be made into a new bottle. But that's not often the process, right? We have t-shirts that are made of PET. We have a lot of plastic that goes into carpet. It goes into all of these different materials that isn't necessarily a bottle-to-bottle type system. And the same thing can happen with other types of materials. So glass doesn't always go back into glass bottles. Aluminum doesn't always go back into aluminum cans. And so what you see from these different figures looks at those variables for how materials are managed after they're collected in recycling. So just looking at the blue one, that's greenhouse gas emissions. So this shows you for those common recyclable materials, glass, aluminum, metals, plastic, ferrous metals, plastic, and fiber. So fiber is paper and cardboard. All of those different potential end uses for those materials and what the potential greenhouse gas emission savings are from recycling them. And you can see it ranges a lot, where, I mean, for paper particularly, that's a pretty big range there, going from, you know, a really high reduction in greenhouse gas emissions of almost 320 to an increase in greenhouse gas emissions to 150, depending on how that material is used after it's been collected. The one thing that you do see is that for aluminum, right, aluminum, it varies, but it's all under the 0 bar. So pretty much no matter what you do when you're recycling aluminum, no matter what it goes back into, it is going to result in some greenhouse gas emission reductions. And then for the other materials, you know, they're a little bit closer to the 0 bar, and there's a little bit, you know, sometimes they're better, sometimes they're not, depending on the end use. And then you see something similar for energy use, where for a lot of the materials, and for the most part, there is some reductions in energy use associated with recycling those materials, but it still does vary a lot depending on the end use of that material. So are there scenarios where recycling doesn't make sense? I mean, if you look at that figure, you certainly could see where there are some situations where it might not make sense. Are there situations where the benefits do not outweigh the costs? And like I was sort of hinting at, it really depends on how the material is used. And to really further highlight that, this is looking at it's some research done by Enviros Consulting, not by us, but they looked at different potential uses for glass after it's been recovered from recycling. And it really depends on how the glass is used. So if you look at this figure, it shows you different potential end uses of glass along the bottom. And then the y-axis is CO2 emissions savings from recycling that glass. So when you do glass and you go from container to container, which is that first bar, you do definitely see CO2 savings. But it's pretty often that glass doesn't necessarily go bottle to bottle, right? It gets ground up and turned into aggregate and used in construction type projects. It can be used as road base. It can be used for a variety of different things. But ultimately, rather than turning back into a bottle, it gets ground up and put in the ground, more or less. And when you do that, you don't end up with any CO2 savings. You end up with an increase ultimately in CO2 from that particular use of glass. So in that particular instance, maybe you've recycled the glass, but it's not actually resulting in any sort of greenhouse gas or environmental benefit. And so I think kind of the highlight here is that when we're doing these life cycle assessments, it's really important to consider all of the assumptions that are being made. And in particular for recycling, a lot of times they're making an assumption that things are going kind of in the best possible option, and that's not always the case. So kind of just to recap what we looked at in this study, ultimately we found a 2-bin system is the best, depending on the assumptions that were made, where you have a landfill and recycling bins. And so diversion and increasing diversion rates is a very popular policy tool that's currently being implemented in a variety of different states. California, a big example of that, where they are requiring organics diversion from landfill so that food waste goes to compost facilities. And that's great. And, you know, this study really only is kind of a narrow piece of that. But when you do look at the greenhouse gas emissions associated with different collection scenarios, we do see that having that third bin for yard or yard and food waste collection isn't necessarily the best option. So more diversion is not always going to be the answer. And then, so bullet point number 3 up here is kind of what I was just saying. There's not always going to be a positive offset from recycling. And number 4 also kind of repeats the idea that it really depends on how the material is being used as to whether or not recycling is going to be the best option. So that's all great, you know, so recycling is good in some cases. Recycling might not be great in other cases, but how much can we really recycle? You know, materials can't always be recovered. And there are different ways that things can be lost from the system. So in theory, it'd be great if we could recycle 100% of everything. That would certainly get us towards a more circular economy, right? But, you know, do you always recycle everything? I mean, are you always in a position where that's possible? Do you always know what the right option is? You know, there's a lot of consumer behavior aspects to this where it's challenging to know what to recycle and when. And so that results in mistakes and things getting lost from the system that could be recovered and ultimately aren't. And then, you know, there's just variations regionally where some places have the ability to recycle, some have a facility close by and other places might not. So that's another point where there are materials being produced in the system, but that we can't necessarily recover those materials for, you know, lack of infrastructure, consumer reasons, just other things, you know, contamination of somebody, you do it right, but your neighbor does it wrong. So the whole vehicle that collected that streets of materials is, you know, contaminated, and so it can't be used. That makes it possible to get to this 100% of everything being recycled. And so one of the things that we did was using some Environmental Protection Agency data. We looked at what this theoretical max of recycling is. You know, if we were to get everything that could possibly be recycled from the waste stream, how much is that? And that's what you see here. So based on the EPA's waste composition data from their facts and figures report, which they put out every year, and it shows kind of how much material is generated for all of your conventional recyclables. So metals, aluminum cans, steel cans, plastic bottles, paper, and cardboard. For all of those different materials that are produced and generated in a year, how many of, you know, if all of those were recovered, what would be the recycling rate? And so based on that waste composition data, so even if we recovered everything that could possibly be recovered from the system, our maximum recycling rate is still less than 50%. So if everybody did it perfectly, we can still only get about half of what's generated in the US each year. And it changes. So waste composition has changed over time. There's a lot less newspapers than there used to be. So that means, you know, that's one thing that has resulted in a changing waste composition. And one reason why you see this kind of decrease as you get into the late 2000s, because there are more materials being generated, but potentially fewer of them that can ultimately be recovered for recycling. And then looking at this kind of on the bigger picture perspective. So, right, there are goals to increase recycling rates where, you know, right now our recycling rate, according to the EPA, is kind of a little bit less than 30%, depending on whether or not you incorporate food into that. But when you look at the recycling rate versus this theoretical rate, you can see that there's a gap. And what's reflected in that gap are those kind of recovery efficiency things I talked about. So consumer behavior, how effective are people at putting things in the bin, processing losses. So not only does it matter in how effective you are, the system may result in some losses. So that's kind of the contamination. If things aren't done properly, some of it needs to be disposed of, and that'll result in some efficiency losses. And so that's where that gap is from what's theoretically possible and what's actually happening. And in order to make this all be better, ultimately we need markets. So, there needs to be a place for everything that's produced to be recycled. If you're producing materials and products that can't be recycled, then we're not going to be able to increase the recycling rate. So in order to have the whole thing shift up, we need to improve manufacturing efficiency and also make sure that there is a high demand for recyclable materials. And then, so that really wraps up the presentation, so recycling definitely does make sense in a lot of instances, but it's important to be aware that sometimes it might not. So it just really depends on the situation. And I'll stop there, and I'm happy to answer any questions.
Kind of like a three-part question. Can you hear me?
Yes, I can hear you.
For the multi-bin comparison study, so the first part of my question is, what is nationally, how many landfills use this methane capturing process that puts back into the energy system? The second part being, I'm curious because I'm surprised by it sounds like the implications from the results are that community composting isn't necessarily beneficial. And so I'm curious if those results would stay the same based on the current landfill gases processing methodology. And then the third part of the outputs for that study, was that based on like an average urban or rural area with an average population, or what were kind of the criteria for that?
And if the questioner can introduce themselves briefly, it's hard to see who's speaking, that'd be great.
Sure. My name is Nicole Mazzoni. I am a staff member with the Voinovich School in the Energy and Environment Department.
Awesome. Thank you. Now I have to remember what all the questions were. So I'm going to work through probably the first one was as to how common the gas capture system that I mentioned for landfills is. So I don't know general numbers off the top of my head. I could point you to the EPA for better data and their landfill methane emissions program. But it's my recollection that most landfills do some sort of, they have to have gas collection systems in place. So anything that's relatively newer is going to have that system in place where at a minimum they're capturing the gas and it's being flared to CO2. Not all landfills are necessarily going to, although I think it is a large number of them do capture gas and then have it used for energy. It's unusual for landfills at this point to just emit methane without any mechanisms in place, at least in the United States. But as to a specific percentage breakdown of X, Y, and Z, I don't know off the top of my head, but I could get you that information if you want. I think the second question, or the third question, was kind of for the systems modeled, was it an urban context or rural, or how was that part done? So I think it was just kind of general averages for locations that have curbside collection. So in a rural instance, it's probably going to be less common. Rurally, more frequently, people need to take their own materials to kind of a transfer station or something like that. So it would reflect more likely urban averages for urban and semi-urban type situations. And then the second question, you're going to have to remind me. I don't remember what that one was.
Oh, I think it was just that I was surprised by the community composting, how that get less emissions. And so I wasn't sure if that result would stay the same based on, whatever current process most landfills are.
Yeah, so, I don't think the results should be used to say we shouldn't compost. There are still a lot of benefits to collecting food and yard waste. And it really depends on the system. But I think based on the model estimates and the assumed landfill operation from this study, there definitely are some disadvantages to sending or to collecting those materials for composting. I think that's sort of a vague answer. But I guess the point I want to make is just, this is just one study. There are benefits to composting in terms of greenhouse gas emissions reduction. It may not be the best option, but it really depends on how the landfill is operated.
That's great. Thank you so much.
Sure.
I have a question.
Yeah.
Hi, my name is Caitlin Roush. I'm a student in environmental studies and economics. I was curious if it didn't seem like this study factored in like combined anaerobic digestion and compost systems, which are commonly used in Europe, as opposed to just, kind of vanilla compost. Which it seems like you're kind of treating landfills like their anaerobic digestion systems with those kinds of equations of like that you're factoring in that like if you save the methane and then supplement it for something like natural gas, of course, you're going to have a lot of emissions reductions. But I was just curious if you did any study on like comparing to a combined anaerobic digestion compost system where you have 3 collection bins and the results of that kind of thing, because I feel like that this is kind of a less efficient version of an anaerobic digestion system if you're actually capturing methane in a landfill.
Yeah, so that's a good question. So I do think, there are different ways that materials can be handled, and anaerobic digestion is also a good way for doing collection of materials and then associated energy recovery of those. This does not factor in potentially having kind of a site. I mean, it sounds like you're talking about a site where you would have multiple different processing options at the same site. If you have a landfill, but you also have an AD facility. And so this doesn't really consider that sort of situation. Typically, I would think that if you were collecting materials and they were going to anaerobic digestion, we would have needed to incorporate another process into this. And you're right, we didn't necessarily do that. So, it's not the end all be all. It really is looking at kind of this comparison of landfilling and not landfilling the material, not landfilling, and other ways of processing the material. And, we could end up with different results if you say that. So that's also sort of why I say, this isn't highlighting that composting is bad, just in the context of whether or not you're sending it to landfill or not sending it to landfill. There are advantages to sending it to the landfill ultimately.
Quick follow-up to that, when you're factoring in, kind of a situation where you have recycling and landfill, were you factoring in contamination that might occur from food or other waste in the like energy usage of that situation?
I think we were, factoring in potential contamination rates for looking at recycling and how much material, on a mass basis, how much material actually goes to recycling. But I don't know that would necessarily impact the amount of material going to landfill and contamination. So, there's a certain amount of food that's going to the landfill and amount of gas that can be collected based on the digestion or the breakdown of that food in the landfill. I don't know that we were necessarily anything that then wasn't food or was contaminated from that food would be a part of the general MSW. And just because it's MSW wouldn't be broken down, and it wouldn't be break down into methane and then be associated with recovery from processing those organics in the landfill.
Thank you.
I see we have a couple questions, Susie, in the chat. I know Jane at Athens Talking, she had, I think you were on the next slide, if I recall, about the glass, when you were focusing on glass. She asked if this is specifically curbside or general recycling. And maybe, Jane, if you want to unmute yourself and elaborate, feel free.
No, that's my question is it just general in recycling or specific to curbside? That's all my question was.
Or are you talking about this slide? I think, could you clarify? I didn't quite catch what the question.
I was just, you have recycling. I was just wondering, because the title of the presentation is curbside. I'm assuming that you're talking about curbside programs when you say recycling,
Yeah.
right? So
That is-
theoretically, every time it says recycling, it should say curbside program recycling.
Yes,
Correct.
so the study is focused on curbside recycling, but you could recover materials in other ways, looking at commercial collection and that sort of thing.
Okay.
We have a question from Maria as well. I'll read that one to you, Susie. Maria Bonner, she's from Rural Action Zero Waste Program. She asked, what was the average distance in the calculations from bin collection to landfill, recycling, and composting facilities? Is this assuming these 3 bins are all going to different locations?
That's a really good question, and I'd point you to the report that we have on this for more information. I don't know what the specific numbers are, but I think they were all kind of average values on how far these different facilities would be located from the point of collection. I don't know that it, yeah, I think industry averages for where all of the different facilities would be collected is my answer, but I think the report would have more specifics.
I have a question. My name is Laura Miller. I'm a student in the Voinovich School in the Master of Sustainability, Security, and Resilience program. And I was curious, since a lot of the curbside recycling companies are for profit, if not all of them, are you aware of any policy in place on either a federal or state level that requires them to take these cost analysis into account when determining what they should recycle or who they should resell those products to?
Yeah, so it does depend. There are a lot of municipality and publicly operated facilities and a lot of collection that is done in a public context, as well as the for-profit. But I think the situation with recycling, and often the challenge, is that it's market-based. So they're collecting these materials, and since they are in the case of a for-profit organization, they're dealing with these things based on the market rates for what they can get for different materials. That kind of plays a role in what they collect and how that process happens. So there aren't any policies or regulations that specify what materials or how much materials or what needs to happen with these materials. It's really all dependent on the recycling facility and the hauler that is responsible for collecting those materials. I guess I would just also say that they do tend to try and be, right, when you change things, the system becomes less effective. So I think they're sensitive to the fact that maybe they don't have a market for a particular item at that point in time, but if it's been a part of a consumer or a customer program, changing that because now there is no value or no market for that item isn't necessarily in their best interest. The values, these all are on the open market. The values for these different things change pretty regularly. And so, they might not be getting a profit from the, recycling of, HDPE plastic or from cardboard or a metal at a certain time, but they're not going to change your program because if they're changing it every time that the market changes, people are going to be so confused, they're not going to know what to do. So I think they tend to stay pretty standard regardless of whether or not the markets for these different materials change.
Thank you.
Another question in the chat from Z. Says, in a pre-cycling sense, which materials would you say are the best to avoid as a consumer?
From a life cycle perspective, I guess I would say, one answer is it's just best to, as little as you can avoid as much as you can, right? Reducing certainly will reduce the amount of waste that you generate by consuming less. In a material sense, it really depends, kind of back to that market question. Markets are really important for determining whether or not materials can be recovered. And so right now, maybe it's easier to say what is good rather than what's bad, right? Like metals are pretty easily recovered. There's good markets for them. They're high value. So the more metals you can buy or, in terms of packaging, there's definitely an advantage to that. Things that are not recyclable are best to avoid. So styrofoam can't really be easily recycled. So that's something that you'd want to avoid. Plastic is sort of a mixed bag at the moment. There are markets for a lot of different plastics, but it just really depends. And I think there's a lot changing on the plastic front. But you want to get things that can be recycled. So in that instance, single-use plastics would be something to avoid. If it's a plastic and it can't be recycled or recovered, that would be something you would try and use less of.
Thanks, Susie. Guys, we have a hard stop at 1, so we have 5 minutes left. So probably time for just one more question. Feel free to just unmute yourself or draw a question in the chat. Jane, you want to go ahead?
Yeah, I was wondering if the 2-3 bin approach would still go if you had a compost 1 week and then recycling 1 week or garbage 1 week, so that you have like every 2 weeks you would pick up recycling, every 2 weeks you would pick up compost or something like that. Would that equal out to be it, or is it inherent in the compost or yard waste? Because in Ohio, you can't put yard waste in landfills.
Yeah, so I think there's definitely options, so these are 4 narrow scenarios. If you want to adjust them, there are certainly options where, maybe you could change these different offset numbers depending on where you put the materials. If we changed whether or not it was going to a compost facility or anaerobic digestion, or potentially the frequency of collection, that could certainly change things. So having not run those analyses, I don't know for sure. But I think that for absolutely, there are probably different scenarios we could model that would potentially, give us a different result that would make composting and yard waste collection or a 3-bin system look more favorable. Another alternative would be, there are technologies now coming available where potentially we could extract the food waste from the MSW. So it all goes in 1 bin, but there's some sort of on-site processing facility at the landfill that separates out the organics and then compost them on site. So there is potential for technological improvements too, which could change the dynamics of this situation.
Thank you.
So I'd like to, you're talking about life cycle assessments and this kind of doesn't seem to have the whole life cycle in it. There's a lot of other factors that come into play with all these things. And seems like when you look at some of these larger perspectives, it would change the outcome a lot, like extraction and a lot of plastics don't end up in the landfill in the first place. I mean, there's all kind of other factors, jobs and economic multipliers, that exist with local handling of waste or going with large companies that are just, pretty narrow focused on recycling their landfill, not necessarily compost. I don't like in a rural area, a lot of trash is burnt in backyards or dumped there's so many other things coming into play here that can change the importance of looking at one strategy or another.
Sure. I mean, life cycle assessment is just a tool, right? There are always other factors at play. I don't think I agree. I mean, I think this doesn't cover the entire lifestyle cycle of, right? We were looking at municipal solid waste. So it does cover the extraction, the processing, the use and disposal of MSW and its full life cycle. But it doesn't consider policy. Life cycle assessment is just always limited by the assumptions that you make, and there's certainly instances, it also is impacted by what your priorities are, right? This is only looking at greenhouse gas emissions. If I was really interested in water conservation or land use, I might have different results from this analysis where, purely hypothetical, right? Landfills require a lot of land. So if I was interested in land use, compost facilities have a much smaller footprint. So maybe that would give me a different result, highlighting that really everything should go to composting. Completely made up. I don't really know what the result of that would be, but I think you're absolutely right. There are a lot of other factors, and this is just one way of looking at sustainable materials management and giving us some idea of what potential policy options could be, but you really need to look at all of the different scenarios to really understand, and it's all really locally based. We don't necessarily want to be, we're limited in how far we can transport materials. So it might not make sense in a rural sense if the nearest landfill even is 100 miles away. That's going to change the dynamics. Or if the nearest recycling facility is really far away, that will change the dynamics. So kind of to one of the other questions about what the different distances are, this is based on average distances in a certain context. In a different context, like a rural context, it might not apply.
So Susie does have a hard stop at 1. I just want to remind everybody, and we're a little bit past. So if we can just thank Susie for a great presentation, really wonderful work, as well as we can virtually. And thank you so much, Susie, for joining us. I really appreciate it.
Absolutely. And if you guys have any additional questions, feel free to reach out to me. Happy to answer anything else you might have.
Thank you so much, Susie. Appreciate you taking the time, and I know you have to hop off. For the rest of the folks here, again, thank you for joining us, and thank you, Susie, for all of this great information. Please save the date for our next public service perspective session. We have these on a monthly basis, folks. The next one will be March 24th. This session will be with a Master of Public Administration alum of ours at the Point School, Danica Withers. She'll be talking about advancing equity in public service, and she is currently in her role as the Chief Economic Equity and Inclusion Officer at the Office of Diversity, Equity, and Inclusion at Franklin County Board of Commissioners. So you're welcome to join. Thanks so much, and have a good day.